Hi, this is Adi
Not Vance.
from Team 9225 Dynamite Social Club. Okay, so what we initially started out with is trying to brainstorm a couple of launchers so that we could launch, like the main part of this event is, I'd say, launching the artifacts into this goal. And so we basically considered a couple options. So we landed on these rollers that rotate outwards as we'll demonstrate. Right, so that's like what we ended up landing on. But we also considered like another option is a catapult to kind of catapult the ball into there. But then we landed on this because we thought that we could get the shots out faster and get more artifacts into the goal. So that's how we end up with that. And that's what we had initially, and then some ways we've improved upon that design in the past couple hours is we have this sort of cage that kind of holds in three of the balls, right? And so we can contain the maximum 3 artifacts into our robot at one point. And so, and then we also have a servo back here that pushes the lowest ball into the wheels. Hold on, 1 second. Yeah, and then it'll fire into like that. So it'll get pushed into the rollers, and then the rollers will have ball fire out, and then the second ball will just drop down all the way. And so it's a pretty easy way for us to fire 3 balls consecutively and kind of score artifacts. In terms of our plans of improvement for the future, we plan on having like an actual intake so that we can intake things from the ground and not have the human player have to drop the artifacts into this cage, because that's the only way we can intake any artifacts. And another improvement obviously is to have an auto that can detect this April tag off of the obelisk and place the artifacts in a certain pattern. So currently those are our plans for improvement. If there's any questions, welcome.
What do you think is the most challenging aspect about this year's game?
I think the most challenging aspect, obviously, like from first glance, I'd say it would be fitting 2 robots into this zone. So that's something we kind of are, we're not prioritizing that for now because we feel like if we try to perfect the other options of the game. But I mean, the other challenging part I would say is to coordinate the patterns with your teammates and to make sure that you get them in the right order to get the maximum amount of points. So I feel like you have to have a really good system to be able to do that effectively, and so I feel like that would probably be difficult.
We'll ask one more question coming in from chat. In terms of shooting, obviously it's early on, right? There's going to be inconsistencies. What are some of your plans to improve your accuracy?
So right now we noticed that we have certain, like this distance is what we shoot from if we have the maximum amount of battery. And so what we were planning on implementing is sort of function that changes the power of the motors relative to how much battery is left in, or how much battery we have. So the lower the battery obviously use more power in the motor, and then the more power, or the more battery we have, the less power. So trying to find that like medium to adjust so that we could shoot from a consistent place and not have to kind of test it out during match, which would obviously be not great. So that's probably like the way we would try to be consistent.
Wes, one more question before I let you go. What are by the end of tonight, where do you want to be? What's your expectation?
Yeah, tonight we want to start off by getting an auto and actually, at least doing something for auto, getting a start, because right now we don't have any. And also just like trying to find our happy place in terms of where we shoot from with a healthy battery. So that's probably.
All right, well, thank you so much for showing us. Give a big round of applause to everybody for their awesome progress. This is really cool, by the way.
Studica Robotics is inspiring teams to build better robots with their new array of FTC team options. Check out their updated bevel gears and Maverick hex shaft motors, Planetary gearbox options, and 6mm hex components and shafts for extreme power transmission. Go to Studica.com/robots to learn more and apply for discounts.
So, my name's Will, and this is Isaac, and we're part of Team 868 Crack and Pinion. And so, our design was we wanted to be able to intake artifacts from the game field and then also be able to shoot them. So we have this sweeping mechanism in the front that will spin off of a servo. So if Isaac wants to spin it. So one thing that we did realize that we are going to change is that it's not stiff enough to take in the elements. So we will also be through the night working on trying to make it stiffer so we can take it in. And then Isaac, if you want to switch the bot around. We have these 2 foam wheels that were from Andy Mart that we just had lying around from years past. And we have them mounted that it will shoot the ball up at a steeper angle so we don't have to be as far away from the scoring spot, so we don't have to have a huge distance. Underneath this, so to engage the artifact into the outtake, we have this little servo. So Isaac, if you want to flip up the bot. So at the bottom, there's this servo at the bottom to kick the artifact into the outtake rollers and then shoot it. So we can then not just intake and then outtake. We can actually like intake, wait, drive, and then outtake. Anything else? No.
So obviously nothing fully shooting it on this, right? But using this in the air. So where do you expect to be when do you expect to be shooting? We're testing out that next prototype.
In a few hours. We have it mounted. We just need to get the control hubs and battery mounted, then we should be able to test and see it. So next few hours.
Can you talk a little bit more about the prototyping of the intake? Like, have you done any like testing on the viability of something like that yet?
Yeah, so we've been testing it a lot. We do think the servo is going to have enough power and speed to take it in. If not, we will then switch to a motor, but I have confidence, and we're going to take this rubbery tubing and attach it to the intake to make it stiffer and have that be stiffer and be able to take in the element.
Can we turn the robot around real quick so the intake's facing the camera? So right now, are you only able to pull in one of the artifacts at a time, or is the plan to be able to pull in multiple artifact pieces?
So as of right now, it can only hold one.
Cool. And for you, are you looking at potentially doing more for Robot in 30 hours, or for this specific use case, is it going to be one?
I think for this specific use case, just with the time, I think it would just be more beneficial to get one and have it work versus get 3 and not have it work.
Any other major things you guys want to accomplish in the Robot in 30 hours? I mean, Crack and Penny's been doing this for quite a few years on it. So by the time you get done with Robot in 30 hours, what are kind of the main key goals you also want to accomplish?
I think another key goal would be, I think we can get an auto program by the end of this, and then just with this time using our other team members, because we have a big team, just catting what our later season robot and if we can hold more elements and be able to score more accurately.
All right, Crack and Penny, good luck the rest of the way. Give them a big round of applause, everybody.
AndyMark is your one-stop shop for all things FTC. Teams who are looking for inspiration in DECODE can check out AndyMark's Robotics Core Kit and FTC Starter Bot, which are designed with usability and accessibility in mind. And check out some of their new components suitable for any FTC robot. Head on over to AndyMark.com to find solutions that fit your team.
Hello, my name is Raphael, and this is Eric, and we're from Team 26691 Thunderheads. So, we've been working on this robot today. Our current idea for this design is 2 wheels, right, that spin to intake the artifact and then can hold it while we drive around to the launching zone, and we can then reverse the direction of the wheels and bring down this motor spinning these wheels to launch it into the container. So yeah, we can give a demo of it right now, I guess.
Okay, before we give a demo, I'm going to talk about a little bit about how we reached this design and sort of the steps we took to get here. So at first we started with basically this Y shape. We'd bent one of these metal plates to allow for like a reservoir to hold the artifact, and we had the wheel spin the artifact into the intake and the outtake. So the problem with this design was when we tried to outtake the artifact, the wheels up here didn't actually have enough time to speed up before they could launch it up into the depot. So we added this this motor here to be able to come down and push it into the wheel after we give enough time for the wheels to get up to speed, so we can actually get it into the depot, hopefully.
Yeah, and another problem we had was just the motors weren't moving fast enough. So we had to sort of replace them and workshop what motors we were using and what orientations to get the wheels spinning fast enough to launch it. Yeah, so the next steps we'll be taking to work on this is a lot more stability if we can on this mechanism. As you might be able to see, it's very wobbly right now with the way we have it mounted. So we'll be working on that. We'll also be working on fine-tuning the movements of this, so the speeds of these wheels, you know, the angle, like the angle in comparison to the ground that it's at. That's what we'll be working on after this. Alright, so we'll move into the demo now. Eric will narrate it.
Okay, so we're going to bring the intake down so we can actually intake it. This is our first test, so I'm not sure if it's going to work. Might need a little help. There we go. So now we have it inside of our intake, and we're raising it up the angle, and we're going to come up to the depot. Wait, hold on. The order of events was a little off. Okay. Yeah, okay, now lower the... And there we go. So aim was a little off, but you can see the concept. Let's try that again. So that's intake. Let's turn over. Bring it up. Oh, and overshot it a little bit too. But hey, we'll keep working on that.
What are some of the ways you're looking at tuning the robot a bit more? Can you kind of go through some of how that testing process works?
Yeah, so I think some of the main things we can tune on this robot are we could add another mounting point here with the rec shaft coming across so we can actually stabilize the outtake while shooting. I think we're also going to do some testing of angles to try to find like our most optimal angle for launching the artifact into the depot. And some other things are we probably want to start working on some autonomous soon. Maybe see if we can get that working and look at the April tag some more as well.
Yeah, and another stretch goal we would have is if we're able to, if we can expand this backwards so that we can hold like more than one artifact, like at least two, because that would, you know, increase our scoring capacity a lot.
There's a question here from a chat from Payne. In terms of your arm that's actually moving it, what are you doing to try to get them to be a bit more stable or accurate for you?
Yeah, so in terms of rotating this up, we're planning on adding another support here so that we can send the rec shaft that's connected to this worm drive all the way through, so that provides 2 points of contact, which basically makes it, you know, a lot more stable.
I just want to check in. What did you guys have something in demo as well too? For you guys, okay. Why don't we bring them in? We'll demo that as well too.
Sounds good.
And then hear a little bit more about the Thunderheads.
Yeah, so we've also been working on a second design within our team, so I think they're bringing that out now to show you guys.
It's not the mics, it's the PA system.
Yeah, so the second half of the Thunderheads team, we've been developing a similar design. So our design is basically we're going to start off with a ramp, similar to what we saw in the game reveal video. And we're hoping to like hold 3 of them. And then it goes up here, and it's powered by these 6,000 RPM motors. And then it'll shoot it up into the depot. Alright, so we can demo that for you right now. Let's bring it back. Oh, yes, sir.
We're going to eventually attach this and then have it go up the ramp.
Yeah, just like that. So as soon as it goes in. All right, Marshall can talk a little bit more about how we came up with this design.
So we decided originally with the outtake that it would be easiest to just have two wheels that launch it, and 6,000 RPM motors when we let them speed up would be the best for that, since we don't really care about torque. So we attached two of those to some gecko wheels, and then we tested it and it worked really well, so we stuck with it.
Yeah, originally we actually had a piston idea where we have a piston that hits the ball up. We have a sample of that. It's just not here right now. But we found that didn't have enough power, so we went with this new wheel design.
To clarify, the original idea was that we had like a rack and pinion design, and then we had a flywheel that could spin up and then connect pinion gear, which would shoot the rack up when needed. But it had a major flaw, which is when the ball was above it, if there was a hole above it, the rack would just go through the hole, and so it wouldn't be consistent.
Oh, that's a great question. I think around hour 25, we're gonna bring them onto the field, and we're gonna see who can score more, and then that's how we decide. We like both designs. I mean, they're both pretty similar. So yeah, I guess we'll see at hour 25.
For over 100 years, Kettering University has offered a better education because from day one, that education has been built on hands-on, co-op learning. Kettering's impressive alumni network includes founders, presidents, CEOs, and frontrunners who have a reputation for transforming industries with their resolute leadership. Apply today at kettering.edu/first.
Hello, I'm Dominic from Team 9224 TechnoGoats.
I'm Anders.
And we right now have a drivetrain and a storage and part of a launching mechanism. So here balls drop in there, and down here we have gecko wheels connected to a motor that will then spin and shoot the balls into another part that'll have more of this flexible plastic so we can angle it up and into the scoring locations. We started looking at using both catapult or this. We decided to go with this design for 30 hours today just because we thought it was simpler and had a better chance of working. Some things we're looking to add right now is some sort of gate to hold the balls in the storage area before they contact the gecko wheels, so we can control when we launch them. And then we also need to attach it to our drivetrain. We also are looking at testing to see what angles and locations where we should launch from for our launching section.
Have you guys tried anything else in your prototyping? Was this like the first thing you came up with, or did you have other ideas that maybe you didn't go with?
We did have the idea of a catapult, but we decided not to go with that because we thought it would be a little more complex and that we may run out of time.
Good question by the Future Innovators Academy. What is the size of your drive base?
The drive base is about 15 by 13 inches. So we decided to go something a little bit smaller so we'd have an easier time fitting in the base zones and maybe also having our alliance partner join us.
And then will there be an intake on this robot? And if so,
no.
Okay, so no intake.
So our intake right now we are planning on getting from the human player.
Perfect. As you go through this progress in here, we asked the team earlier, what do you think is going to be the most difficult aspect of this game?
The most difficult aspect for us might be properly loading it and also fitting, seeing if possible to fit fully in there. Although that we mostly have covered, we don't know how big the rest of the chute is going to look like.
Studica Robotics is inspiring teams to build better robots with their new array of FTC team options. Check out their updated bevel gears and Maverick hex shaft motors, Planetary gearbox options, and 6mm hex components and shafts for extreme power transmission. Go to studica.com/robots to learn more and apply for discounts.
Hello, we are Team 4116 Volta Robotics. My name is Elias.
I'm Peniel.
And I'm Nathaniel.
And we're going to show you what we've got so far. So first is Peniel with our...
So we first made so one of the first things we wanted to do was make a launcher, since we thought that would be the simplest thing to do. Turns out we were wrong in that respect, but we would like to give a demo of this.
You might want to get out of the way. We don't have the hose. Alright.
So this is the iteration we are going with now. We used to go with a different type of wheel here, but we changed to foam wheels after the advice of our teammates because, well, this is the first iteration. We had instead of the foam wheels, we had these, and these wheels were not big enough, so we added like a bunch of rolls of tape to it. But the problem with that is these are 6,000 RPM motors, and these tend to deconstruct a lot. And we had a couple of accidents, but we decided to soon change to these foam wheels. We found it in those bins there, so I'm assuming it's probably. Ready? It's on. We're having some connection issues at the moment.
You want to move on to something else first?
Okay, yeah, we will. So,
So my part doesn't have too much going on for it yet. We decided to get a little ambitious and start working on an active intake for this challenge. So I've got this motor and a couple of shafts connected to these rubber wheels, which I thought we could mount onto the back of our robot and have it spin so that the wheels could intake the artifacts, and we could shoot them off as fast as possible for the game. But right now, it's just a motor with a shaft and wheels. It's effectively just a concept right now. So this is what we're going to try, and hopefully we get it working soon.
Have you tried different types of like either stars or wheels or anything like that for your intake before? What made you choose these?
So we choose these just because these were the most available. Like
Sure.
we had these already on hand. We thought they might work. This is our first time really trying it. So we're going to see if these work, and then if they don't, we're going to change to a different type of wheel. But I have to finish building it first.
And the final thing that we have is we have programmed a system for automatic aiming. Just move out of the way right there. It looks at the April tag and automatically aligns the robot so that it's facing straight on to the April tag. This design was inspired from a comment of one of my teammates on video games, actually. Especially with games like, he said, Elden Ring, where it kind of locks on to an enemy.
So what are you using for then?
We are using the built-in April tag detection software in the FTC codebase.
Looking at the game you guys are at, so where do you want to be by the end of tonight? What are some of your objectives?
By the end of tonight, I would say that we want to get the launching mechanism onto our robot and make sure that we can get a camera mounted on the main drivetrain.
So you guys really get this detection, I mean, very quickly, right? So what advice do you have the teams who've never done vision before? How easy was it for you to do this? And then if a team just picked this up, like how easy is that progress or process to do that?
So most of the code in this was taken from the official FTC examples that they have kind of, and it's kind of hidden in the code base. But if you find the samples folder, there's a whole list of a bunch of sample programs that you can draw code from. And the one that I'm drawing code from is it's a program for the robot to drive up to an April tag using Omni wheels. And I just tweaked the code so that it only changes the rotation of the robot rather than the position.
Yeah, I think your teammate's ready to showcase off your shooter. Let's give that a shot.
So we actually have not tested this on the field yet. We've tested it in the hallways, and this seems to be pretty effective. So yeah, this is gonna be a new experience for us too. We have not tweaked the power yet. This is still at maximum power. We just wanted a proof of concept. You can turn it off now. Turn it off. Turn it off.
So maybe we'll be scaling that back over a little bit of time.
Yeah.
Huh?
This is more of a proof of concept. We have not tweaked any of the code. This is only going full power. But yeah, this is all launcher.
AnyMark is your one-stop shop for all things FTC. Teams who are looking for inspiration in DECODE can check out AnyMark's Robotics Core Kit and FTC Starter Bot, which are designed with usability and accessibility in mind. And check out some of their new components suitable for any FTC robot. Head on over to anymark.com to find solutions that fit your team.
Hi, I'm Tyler from 20293 LaserBots. To start off our build, we had to choose between a large chassis and a small chassis. Overall, we chose a small chassis because of the endgame square. We wanted to be able to fit both robots either in, or one completely in and one partially in, to get those extra points, because we thought those points would be very helpful at the end of the game. We also did some pre-programming stuff to get ready for the build, such as doing motor test programs and Mecanum drive programs, just to be ready for the build. And then during this build, we've kind of been coming up with multiple ideas at a time and testing them all.
So currently we don't have any intake, and our plan is to push the artifacts to our human player so that they can load them in. And we did this because we wanted to focus on getting a very good launcher into the baskets, and then eventually, if we have more time in the 30-hour build, we'll focus on trying to build an intake for our robot. But right now we load it in through the top, and it falls down into our launcher, and then it hopefully launches them into the basket.
So for our shooting mechanisms, we had two original ideas, which were a catapult and the wheels that we have today. And so we decided not to do the catapult because it just didn't end up working as efficient as we hoped to. So that's why we switched to this design.
So can you talk a little bit about why did you design so far? What were some of your other ideas maybe you went with, and why was this the best one so far for your team to go with?
Because of the limitations for parts, we kind of had to pick and choose on what we could use, such as not enough springs with high enough tension, and not high enough torque motors or high enough RPM motors too. So overall, we found that the motors that we have currently, which are 1,000 RPM motors, work the best for launching the balls. Even though a 6,000 RPM motor would be better, this is what's working right now, and that's kind of why we've chosen this launcher.
By the way, chat wants to know, are those Freight Frenzy ducks, or are those just off-the-shelf ducks from somewhere?
I was not the one who bought them. One of our teammates went to the store and bought them today.
So not from the game Freight Frenzy back in the day?
If we could, yes, I think we would.
Okay, fair enough. What are some other things you guys want to accomplish by the end of the day today?
Currently, we have a lot of the framework of our robot done. We would like to tune all of the parts. For example, the backstop, we would like to tune that a bit better to get the perfect angle for our launcher, as well as the drop for the human player. We would like to get that a bit better. But overall, we've kind of just gotten the basic framework of our robot working and making sure everything can at least work a little bit.
Anything else you guys want to highlight or cover?
Right now, our robot can do pretty much all of the stuff on the field currently because of our programs and our quick efforts here. But it's not all perfect, so again, we would like to keep evolving throughout this time.
Is this operational yet or not quite yet?
Yes, we both have a wheel motion program and a shooting program.
Can we see how some of that works?
Yes.
I don't think we have the wheels able to move yet, so it can't drive, but it can launch right now.
Program the wheels yet? Oh, yeah.
Yeah. That's part of what we need to fix too later tonight.
Awesome. I think it's a great start for you guys. So good luck the rest of the way. Thank you for telling us more about it. And everybody give them a big round of applause for all their awesome progress. Thank you.
For over 100 years, Kettering University has offered a better education because from day one, that education has been built on hands-on, co-op learning. Kettering's impressive alumni network includes founders, presidents, CEOs, and frontrunners who have a reputation for transforming industries with their resolute leadership. Apply today at kettering.edu/first.
Hi, my name is Ria, this is John, and that's Victor, and we're from Team 16460, the Gearheads from Brookfield, Wisconsin. So what we have going on here, this is a repurposed chassis from last year's season, and the aspects that we've added are this part, which we're going to make out of aluminum later, and then this is going to be our claw. So the way that this works is the claw is going to pick up balls, and then it's going to drop them in here, and it's going to roll down. And then we're going to have a flap that's going to push the ball up, and these are going to be spinning continuously, and then it's going to launch them up.
As you can see, our claw is clearly not attached yet, but we have made sure that it fits just about snugly with the game pieces. We were considering doing some sort of a catapult method of launching. However, we eventually realized that in past seasons, using motors has taken a couple of seconds to spin up, which would not be optimal, and we need constant precision. So we can probably demonstrate a little bit, right? Okay. Okay, so this is just driving, normal driving. Get it? Shortly. Probably.
Take a quick question from chat. How did you get the claw made so quickly, or was it pulled from a previous year's robot?
Yeah, so this same claw design has been used multiple times. The original one was from Power Play, where it was made for the cones, obviously. Since then, we used it last year for a prototype claw before deciding on our final design. And this year, we used essentially the same design, but just made the claws longer using a 3D printer as soon as we found out that it was going to be quite large balls that we were going to be using as game pieces. So you can see movement.
And then from a dimensional wise, how do you plan on keeping that claw within the 18 by 18?
Yeah, so the robot is already pretty small because, again, we used the chassis from last year, which turned out to be extremely small just to get under that barrier that we had in the game last year. So hopefully we will plan to take off this cardboard part and hopefully move it a bit farther inwards, which will then allow us more room to attach the claw. Thank you. Attach the claw to the front. Hopefully giving enough space to match the 18 by 18.
And we're also going to shorten this part quite a bit, so it's not going to be this long. It's probably going to be more around here. And this looks a little bit longer than it is because we have clamps holding this in place, so it'll be a little shorter.
Okay, I think that's about it.
Just one question. What is the filament used in the claw?
Yeah, this is just regular PLA, specifically Bamboo Labs branded. Yeah.
Awesome. Anything else? Gearhead's been doing this for a long time, and also during competition season built phenomenal robots on it. How does Robot in 30 Hours benefit your team, and what do you want other teams to take out of this?
Well, I'd say it greatly benefits us personally, just from the aspect of being able to just knock out our first robot, get some iterations made, see what works, what doesn't. I think that's true for a lot of teams. Just being able to see ahead of time what works.
All right, well, Gearheads, we'll let you get back to it. Give them a big round of applause, everybody, and thanks for showing off your awesome progress.
Studica Robotics is inspiring teams to build better robots with their new array of FTC team options. Check out their updated bevel gears and Maverick hex shaft motors, planetary gearbox options, and 6mm hex components and shafts for extreme power transmission. Go to studica.com/robots to learn more and apply for discounts.
All right, hello, my name is Cameron. I'm from the team Men and Kills 4115.
I'm Nolan.
And this is what we have so far into the 30-hour challenge. Here we can look at our intake. What will be our intake? I want to talk a little bit about
Yeah,
that.
so we haven't attached the intake to a robot yet, but essentially we used this version of an active intake that has these prongs on the side. We're actually going to have them diagonal on the robot, as this will make it so we don't really need a ramp leading up to the robot. Instead, it essentially just picks them up, and it can put it in the chamber.
And then, once it's in the chamber, we will have these wheels that are both connected to 6,000 RPM motors, and these will spin very quickly, launch the artifact up our ramp, and hopefully into the dropping area.
Yeah, and this will be all like encased. It won't be because you don't want it to fall out. But yeah, so we're essentially have everything like built. We just gotta put it on the robot now. That's the phase we're at right at the moment.
Yep, we will also be adding, possibly adding a little bit more structure on the side, so there's less chance of the artifact getting stuck anywhere, and obviously a lot more wire management because we don't want anything dangling off our robot during competitions.
Your team probably picked the largest flywheels, I think, out of any of the teams for shooting. Can you just talk a little bit more, like, that thought process and why you think that's going to work out best for your team?
Yeah, so our thought process was we wanted something to be like kind of central in our robot, and in order to do that with the ramp that we had, in order so that we were able to use these angular pieces, it's a little hard to see, but in order to use these angular pieces to mount our motors at this angle, we would need to have wheels with relatively large diameter in order to actually reach the artifact, and so the artifact would actually fit correctly within our intake, and where it wouldn't just like slide through, because here it will, once they're spinning at full speed, actually be able to successfully launch. Will anyone want to talk a little bit more about that?
I guess all I'd really have to add here is that we added the little squishy things on the end just to make it so what I saw with some of the robots was that as the wheels were spinning, they were almost like grinding up against the ball and slipping. So this is shelf liner right here that we added that eventually essentially gives it a bit more grip on here, which leads to a better launch, we think.
So, Men and Kills, where do you think you're going to be by the end of tonight?
So end of tonight, I think we'll be able to have our flywheels fully programmed, and we'll definitely start mounting, I think, our intake. We very likely will have at least somewhat functional robot by the end of the night, I think.
Awesome. We look forward to seeing it. Let's give Men and Kills a big round of applause, and let's get back to work. Thanks you.
Thank you.
AndyMark is your one-stop shop for all things FTC. Teams who are looking for inspiration in DECODE can check out AndyMark's Robits Core Kit and FTC Starter Bot, which are designed with usability and accessibility in mind. And check out some of their new components suitable for any FTC robot. Head on over to AndyMark.com to find solutions that fit your team.
Hi, I'm Daniel from 1321 Hazmat.
I'm Rohit from 1321 Team Hazmat.
And we're based in Brookfield, Wisconsin. So from last year, we also had a custom chassis, but it was a little bit larger than this one is. So for this year, we still kept our custom chassis,
and we shrunk it to around 13 by 14 and a half inches. In our chassis, we also added a built-in PTO, which we took out for Robot in 30 hours, but we're planning to put back in and see if we can use for our 2-player park. On our robot right now, we've added a roller intake that moves into a ramp with a kind of conveyor belt system right here. We have some code to demo it. So essentially this ramp and the intake will move the ball all the way up to here, where we'll use a shooter mechanism to eventually launch it into the goal.
I think you guys have one of the most elegant processes we've seen so far in terms of doing that intake, that sort of thing. So was some of the structure like already completed? Did you put together like how that channeling works just over the last couple of hours? Can you just talk about how you were able to just get everything put together so nicely, so quickly?
Yeah, so really it's not as nice as it looks. We added a lot of extra kind of using quad blocks and just go build it channels. We added a bunch of like kind of extensions on our original chassis. One of the functions of this chassis is its inner plate, which just has a bunch of holes in the go build it pattern, which allows us to kind of be modular with our design and put as many stuff as we want. So we were able to put kind of on the 4 corners we put quad blocks and channels, and since we already had some built-in mechanisms with these go builder motors, we were able to really easily put together a quick roller intake and a quick conveyor belt system.
Is there anything that your team's looking at doing to keep the artifacts inside the robot, like after you intake them to kind of keep them in?
Yeah, so right now the distance between this channel here and this belt is kind of close enough to that these balls will stay, or these artifacts will stay connected together. Or not connected, sorry, they'll stay like squished in there. It's not tight, but not too tight, to the point that they stay pretty well in there. Eventually we'll have a mechanism to put them up into a shooter, but we're still working on that right now. And then these belts have like not too much tension as well. They're the best that we could do at the moment, so they're also part of the reason that they stay meshed in there, because the belts form around the artifacts.
Other than what you mentioned, any other things you're looking to accomplish during the robot in 30 hours?
Really just trying to make sure we have a good shooter that can shoot from pretty much anywhere on the field. That's just the main concern, considering what we have right now.
For over 100 years, Kettering University has offered a better education, because from day one, that education has been built on hands-on, co-op learning. Kettering's impressive alumni network includes founders, presidents, CEOs, and frontrunners who have a reputation for transforming industries with their resolute leadership. Apply today at kettering.edu/first.